My name is Adel Gastli. I'm going to present to you this third part of the introduction chapter. In this third part, we are going to see some applications of power electronics and highlights its role and its importance. You can find plenty of power electronics applications in the world. They are applied on Earth and space. On Earth, you can find them everywhere, on the ground, underground, on the sea, and under the sea. In space, power electronics is applied in satellites, space stations, space shuttles, airplanes, Mars rover, etc. In the sea, they are applied in electric boats, ships, jet skis, and submarines. On the ground, they are applied in transportation, such as electric trains, golf carts, electric and hybrid cars, electric buses, electric motorbikes, and electric scooters. They are also applied in lifts, escalators, and conveyors. They are also applied in automation and robotics. You can find them in small, medium, and large-scale robots. As I mentioned in part 1, power electronics growth has been driven by the application of renewable energy resources, such as solar and wind energy. Oil industry is also using plenty of power electronics converters for oil pumping, such as the beam pump, that is driven by an induction motor, which power and speed are controlled by power electronic converter. Gas compressors and oil pumps are also applications of power electronics. All of them require electric drives, which include power electronic converters. Of course, several types are found depending on the power source and type of motors used. Household electric appliances are also a good example of power electronics applications, especially in those which require power or speed control. Most of the IT equipment, such as hard disks, printers, plotters, scanners, CD, DVD, and tape players, are also examples of power electronics applications. For underground applications, you can find also applications in artificial lift of oil, gas, and water using submersible pumps which are placed deep downhole. Another underground application is in drilling of wells, tunnels, and also in mining. Now I'm going to show to you a short video that summarizes the role and importance of power electronics. This video is available on YouTube.
Electricity, our most valuable form of energy. No other energy form can be so efficiently and cleanly converted into all other forms of energy for our daily requirements of light, motion, or heat. However, electrical energy has to be transformed again and again on its way from the power plant, the photovoltaic solar module, or the wind turbine to the electrical consumers. This is done with modern power electronics. For example, a photovoltaic solar module produces a DC voltage which has to be converted into the standard 230 volt 50 Hz alternating mains voltage using a solar inverter. On the other hand, your laptop computer requires a DC voltage of a few volts that's rectified and converted from the mains voltage. In many applications, the frequency of an AC voltage has to be modified, such as when the electrical power from a wind turbine has to be fed into the grid with a constant frequency of 50 Hz, despite fluctuating wind conditions. Another example is the frequency converter enabling the speed variation of an electrical motor as required. The role of power electronics is therefore to convert electrical energy as efficiently as possible into the necessary form and to control the flow of power. This is done by means of power semiconductors based on silicon, just like in microelectronics. Power electronics is therefore not restricted to gigawatts and megawatts, but can also be responsible for supplying a mobile phone or heart pacemaker with energy in the milliwatt range. Just like microelectronics deals with processing information, one can describe power electronics as a technique to process energy. The power semiconductors work as electronic switches, while additional passive components such as capacitors and inductors have to buffer the electrical energy. Around 40% of today's overall global energy consumption is electrical energy, and this proportion will continually increase in the next years. One of the key and enabling technologies on the way to a more electric world is power electronics, besides electrical energy storage technology. About 30% of the electrical energy can be saved by consistently using efficient power electronics with standard efficiency levels above 95% for the power conversion. The European Union's ambitious climate goals for the reduction of energy consumption and CO2 emissions cannot be achieved without the extensive use of power electronics. After all, power electronics enables the efficient feeding in of wind and solar power to the grid, the stabilization of the power grids, while the share of fluctuating renewable energies is increasing, highly efficient variable speed motor drives, energy efficient and low emission mobility with electric and hybrid vehicles, energy saving lighting technology, and the efficient energy recovery. Another application for energy-efficient electrical drives is in automotive. This is not only related to the drivetrain, but also to the electrification of the auxiliary units, such as the cooling water pump, the air conditioning compressor, and the power steering. Fuel consumption can be reduced by about 10% with these measures. All of these aspects are challenges that young engineers from various industries work on. At automotive manufacturers and suppliers, at the development and production of electrical drive systems, and at the component suppliers for power semiconductors, passives, substrates, and heat sinks. Intersectoral and multidisciplinary teamwork working towards a common goal, assuring future energy with power electronics.
Expanding power electronics research and development is still an ongoing work. Several countries have created national level research centers and labs to focus mainly on developing certain areas of applications of power electronics. The next video will show you an example of how high-rank government officers, such as the President of the United States, are concerned and interested about power electronics, and how they are encouraging and supporting the expansion of power electronics development.
I'm pleased to announce America's newest high-tech manufacturing hub, which is going to be focused on the next generation of power electronics, is going to be based right here in Raleigh, North Carolina. That's good news. That's good news. So, that's good news. It's great. So, just like the hub in Youngstown, what we're calling the Next Generation Power Electronics Innovation Institute is bringing together leading companies, universities, and federal research all together under one roof. Folks at this hub are going to develop what are called wide bandgap semiconductors. Now, I was just schooled on all this. I'm not sure that I'm fully qualified to describe the technical elements of this. Raise your hand if you know what it is. See, we got some. For all you non-engineers out there, here's what it means in the simplest terms. Semiconductors obviously are at the heart of every piece of electronics that we use every day. Your smartphone, your television set these days, everything. Public research helped develop them decades ago. And then that research allowed commercialization, new products, new services, and obviously not only improved the economy, but greatly enhanced our lives. So we want companies to run with the ball also, but first we've got to make sure that we're also doing the research and linking it up to those companies. Wide bandgap semiconductors, they're special because they lose up to 90% less power. They can operate at higher temperatures than normal semiconductors. So that means they can make everything from cell phones to industrial motors to electric cars smaller, faster, cheaper. There are going to be still applications for the traditional semiconductors, but these can be focused on certain areas that will vastly improve energy efficiency, vastly improve the quality of our lives. And the country that figures out how to do this first, and the companies that figure out how to do this best, they're the ones that are going to attract the jobs that come with it. So this manufacturing hub, right here, focused in North Carolina, Go Pack. This hub is going to make it easier for these wide bandgap semiconductors to go from the drawing board to the factory floor to the store shelves.
Now we've reached the end of Chapter 1, which has introduced power electronics. I hope you have benefited very well from these lectures. Thank you.